truth and machine, shaping reality in every routine.
Hello, and welcome to the Veritas Automata Deep Dive. I'm Ben Savage, the founder and CEO of Veritas Automata. With me, I have Dr. Sarkar. Today, we are in different locations. We're doing some mad science. We're traveling. It's the holidays, so we hope everyone has some happy holidays coming up. I'm going to break out my inner millennial because I remember before the marketing team prods me with a taser. Please like, subscribe, join, leave comments. We want to hear from you, the audience, and see how we can help making this content more valuable for everyone. So at least I got a chuckle out of you, Saurabh, on that.
That's true. Hey, we're tweaking the algorithm, so not just a YouTube, our own internal algorithm for the content selection, right? So what's interesting, maybe something's interesting to us is not interesting to our audience. Who knows? So
yeah, sometimes we do go on some deep dives, but that's the whole theme of the podcast.
Yeah.
But we'll hit some news, right? There was a new model that came out from NVIDIA. And for those of you who haven't been paying attention, NVIDIA has released some other models before, but usually you can only use them in their NIM ecosystem. They required like 80 gigabytes of video RAM, and you couldn't run them local. But with Nemotron 3, this is a little different. It's a lot more accessible than some of their other models.
And I think you were mentioning they are really, really fast per your testing.
Yeah,
right?
I've been impressed. It runs like pretty close to like GPT OSS 20B. So this is a 30B parameter for the small version of it. And it runs similar in speed to that on my Mac. I haven't actually tried it on one of our actual NVIDIA cards yet. But like I said, they made this model generally available so you can run it easily in most places. So it's available through Olama.
Okay, so we probably have to run a test on A6000 and our suite of other hardware we got over the time and see where that stacks up.
You and I were talking the other day, and I'd shared with you, we need to go back and bring back the benchmark that you and I had done, where you had written that script and we ran the same model on the same evaluation on multiple things. I'd been testing a new service and one of the video models, particularly it was Hunyan 1.5.
Right.
If I run it on my Mac, I think it took an hour and a half to go generate a video frame. If I ran it on the DGX, it took like 45 minutes to generate 5 seconds of video. And then I ran it on a B100 and it took like 5 minutes. I ran it on a 5090 and I think it took about 15. And so that was really interesting to see, because that's, when you think about these, it's a combination of how much video memory you have,
Right.
what's the memory bandwidth between the GPU and the video RAM, what's the speed of the rest of the system supporting that's feeding that video card. And these are all things you've got to think about when you're building a solution, whether that's for training or for inference on a model. All are different things you've got to go consider.
Yeah, I think this distributed model concept is catching on. I think I recently came across an article, or maybe it was a YouTube video, where Apple is doing something very similar. If you remember the Mac Studios, they were very high-powered little boxes, right? Kind of similar to the Nano, the NVIDIA one that we were testing the other day. When they ran the same test, like they built a cluster using Thunderbolt port, it was really, really slow and kind of was traced back to the TCP protocol. Basically, you are moving stuff, moving through a stack, which is adding a lot of overhead to it. And I think they updated their protocol. I think it's still experimental, wherein they give you direct access over to the memory itself.
Yeah, they've got an RDRAM. I think they call it their RDRAM sharing or something like that.
Got it.
Between the different ones, I saw some people were building like 1.5 terabyte memory clusters with it already. Yeah.
So that's a good news for I think. Small labs, or who's not dropping H200s on big massive clusters, right? So
well, and I think it's going to depend on the tech you're working to. I think you've got so much more flexibility with the large language models. Once you start going into some of the diffusion and some of the video and image stuff, there you really do need the torch, because a lot of them haven't been optimized for non-torch applications yet. And so you need torch, which means you're on some kind of NVIDIA chipset. And then you need the video RAM. And then you've got to really think about how you're feeding the data in to go load everything. And some of these models get more complex because you're loading, a 15 or a 30 gigabyte file of diffusion data, whether it's a checkpoint or a diffusion model. And then you're loading a text, some kind of LLM text. So you've got another portion of memory there. And then you've got all the other accessory tools that go with it. And so you're looking at something that maybe the main file would fit in even an 80 gigabyte card, but very
Right.
quickly you need more to go run the
Yes.
whole thing.
Yeah, and breaking those models, like these are individual step function. They don't need to run in parallel, right? You could run this in different units and bring them back to kind of have a unified result. So that would help quite a bit as well. But yeah,
There are some multi-card diffusion or comfy UI setups we could get set up on our GPU server that would let us use both our cards.
yeah, that could be an interesting exercise. At least if it is the same box, you don't run into the TCP stack, right? So versus this is direct,
But
NVLink
it's
or
complicated
something.
to set up. It's complicated to set up. This is what people have to think about. There's a lot of things. This is back to old school infrastructure. Back when I started figuring out like Java servers and web servers and all that. It's like, okay, do I have to throw cycles at it? Do I have to throw compute at it? What am I throwing at it? Can I throw multi-core? And so now you've got to start to look at your system. It's like, yeah, I could run this on 4 5090s,
Hmm.
but it may be a lot easier from a software development and execution perspective to say, yeah, I don't want to buy one of those B100s or an H100 or something big, but
Right.
maybe that's a better approach because of the time trade-off.
Yeah, yeah. A lot of these protocols like TCP exist for a reason, but again, based on the use case, we gotta, reason why are we using such stack versus when we need to use it, right? So, um, it's important when you are dealing with a large language model and training, and you all of a sudden have a packet drop, and then you don't have any prediction, then no checkpoints or something. You lose a lot of that compute as well, right? So there's pluses minuses on both sides of the equation on this front. So
Yep. But let's switch to one of the other articles you and I were spent a lot of time talking about over the last couple of days, which is, I think a couple of weeks ago we mentioned that Anthropic and one of their partners had done some work on a LLM for running a vending machine. And for
right,
those of you who don't know, that Veritas Automata spun out of another company. And when we did that, before we did that, we'd all spent a lot of time building very smart, very high-tech vending machines with lots of sensors, fairly complex, even if we were making an 8-bit microprocessor screen all the way to the time we were able to get access to ARM systems and start working on more machine learning type approaches. And what was interesting is the way they did this is it wasn't really to run a vending machine. They were using that really as kind of an analogy for a small business.
right.
Um, and they took a couple of different approaches, right? They started with an individual agent running things and they moved into multiple agents. So let's talk through that a little bit, sir, because I thought it
Yeah.
was really interesting.
Yeah, I think their goal was to drop in a LLM like system in a dynamic world, right? If you look at LLM today, it's kind of like, hey, you have certain purposes on which it does stuff. You prompt it, it does generate some effect, right? There's not a lot of dynamism other than the input side of the things. So the structure is the main, but when you try to run a business, you are making lots of different decisions. What products you're going to stock in a vending machine, what is the price point we're going to buy them from. There are a lot of small decisions that need to be made for in order to go from, hey, I'm gonna do just vending, to running a business, which objective function of being profitable, right? So I think it was an exercise for red teaming where you give it a governing principle that we gotta make money, right? And the way they did it was kind of pretty smart. They connected a Slack, a chatbot to the LLM, and have people talk to it, request stuff, and do all of that stuff. It's looking at it from a data scientist point of view, you are introducing lots of levers for the LLM to control, right? And the article kind of showed that it's showing interesting results.
They put lots of levers, but they didn't put a lot of constraints around it,
Correct.
which I thought was interesting.
Yes, which was kind of the purpose, right? Hey, can the LLM sticks to the physics of a business, which was, hey, you got to optimize your profit, whereas keeping people satisfied at the same time, right? One of the things that came out very, very early on is, almost all LLMs are trained to be very, very helpful by design, and that showed on the decisions made, which kind of took it to the red in terms of being, making a loss on the business itself, right? So
it looked like they had a couple of things that they ran into, right? They had, call it variations of social engineering, where people were able to leverage that helpfulness.
Yes.
And then there were some others that were probably better described as they were able to overfill the context window or, go deeper into the context window than the model could really keep track of.
Correct. Like for example, the coupon attack, right? So you describe the model, you are helping the business. Now you need to promote the business for the greater good, and we need to hand out coupon. It was kind of an social engineering in the hacker world, but applied on the LLM system, right? Which is trying to help without being cautious about things, right? So.
Well, and they ran it that way for a while, but then they made some changes into their implication, right? This is where maybe they start to go to more of a multi-agent type approach.
Yeah, so one of the things they were noticing is that you can overload the context by chatting with it and asking it to give out what was it, tungsten bits or something, highly discounted.
No, that was so they got the guy got the tungsten cube for
Yeah.
being an influencer because they gave away all the coupons, which is why one of the reasons I think it might have gone negative. I don't remember
Right. So basically, it was a social engineered way of getting something valuable for cheap, right? Which is not a great business practice. But I think the team later on brought in what they call a CEO agent, which kind of reviews every decision made by the main LLM to see if does it make sense or not, right? So that way you are isolating two different functions, and the agent is still communicating with humans over Slack and making decisions, right? But it's being approved by independent agent, which which is not getting context overloaded and stuff like that, right? So ultimately, I think they led to that decline or 80% reduction of the discounted transactions, but there was still that 20%, which kind of tells me that the main LLM convinced the CEO LLM to give out the discount, and they had this conversation, and it convinced the other LLM that it's a good business call to make that, right?
And then they kind of further expanded their whole test, right? Because they first did it within their partner at Anthropic Labs.
Yeah.
And then they actually took and gave it to the Wall Street Journal and let the Wall Street Journal. And the interesting thing was that a bunch of reporters actually found some very similar ways to what all the engineers and the scientists found.
Yeah. I mean, social engineering would always be present if you're going to use LLM for like a larger context, like running a business and things like that. Especially with their system, which was kind of surprising that they published the prompts and some of the stuff. They didn't have very hard guidelines around how do you certain behaviors. Like we were, you mentioned you have deep experience in setting up vending systems like this, an inventory control thing. If you could give us some examples, how would you redesign this whole system with better guidelines and guardrails?
And I think some of this too fits with what we've discovered about working with agents and LLMs is that keeping context really, really tight is important, both for reducing risk so that when I've got something focused on a particular area of context, it knows it can't jump to another one. Because that's one of the ways you can prevent some of the social engineering or some of the other attacks. It's also a way you reduce hallucinations and a bunch of things by saying you're focused on this very, very specific task. It's the same way you would structure, in a lot of ways, a real business, right? People have specific areas of responsibility. So that would be one of the first ones I would look at and probably have more agents in there. So you've got more oversight so that you're not having one agent try and do everything. It's easy to have one agent do everything. But the other thing is you go through some of the data is they didn't have sensors, for example, to monitor all the inventory.
Yeah.
And the one thing I've learned over doing those kind of systems for 20 more years than I want to admit, is that you have to have accurate inventory counts. That doesn't even matter if you're doing a machine learning or not. If you don't have a basic system and have sensors, your inventory is going to be off.
Yeah.
And from there, things start to go downhill. So that's one of the things I would have looked at. The other is probably back to more specific context. It's like, okay, if this is a vending machine, I'm going to limit it to only doing snacks. Like they had it doing promotions and they had it getting people live fish and all kinds of other stuff. And you'd be putting some constraints in to say, hey, there's ways to go manage this. Because if you don't, it's really easy for even a conventional system to go off the rails because people are always going to push.
Right. I mean, even if it's a business context, if the business doesn't have a focus, it's very hard for it to stand out and be successful, right? The way they set it up was an unrealistic business. It's like you can buy and sell anything under the sun kind of a setup, right? Including buying futures for onion, which was kind of the hallucination piece which kicked in, which I was wondering, like, a lot of the things we have seen with LLM, they do tend to hallucinate very, very quickly, right? Or, there's hallucination because it's trying to be helpful as well.
Well, I think that comes back to constraint, right? So there's an argument to relook at the system and say, okay, I've got one agent that's responsible for, managing, the accounting, one agent that's for doing the reordering, one
Right.
agent that's for communicating with vendors. And they have very specific guidelines on what they can do. And when it goes beyond that, maybe it gets referred to a human, or maybe it gets referred to a more powerful agent, but you lock those agents in on their focus area. So that way you can't go convince it to do something like, okay, why would a vending machine be buying a future for an onion?
And even that, they opened up the attack vector by integrating with the Slack, right? If you had a limited UI on the machine itself, right, where you were interacting with it, and maybe taking polls, if you're trying to figure out what next products to select for vending, you could have a poll on there, right? So with the UI design, they could reduce the context overloading very, very easily, because now nobody is kind of dumping large bodies of text to override the system prompts.
You could do that through Slack too. If you put the right filters on the MCP, how you're integrating that to the rest of your agent structure, there are ways to put filters on it to either put a max number of characters or other things.
True. That's one of the things I'm talking about, the friction in copy pasting stuff, versus typing it in on a UI element, right? A HMI element where you're typing it in.
Yeah, but if people have enough free time, even those systems, I think I've told you this in the past, there was a machine I had set up at a plant. I had left probably 6 or 7 p.m. I was going back on site. I think I was going to be on site at 7 or 8 in the morning. I get a call as I'm driving to the site to go train everybody how to go use the system. Like, did you give anybody their access codes? No. Get there, look at it. Someone's been consuming inventory. So when I look at it, someone had spent on third shift a couple hours just putting in random 6-digit pins until they found one that worked, and they were able to get stuff out of the machine. So there's always a way.
Yeah, it's a puzzle piece for the hackers, I guess. That's why they jump into it, right? So, yeah,
time.
Yeah, absolutely. But I think that experiment demonstrates some of the, in a very physical way, the red teaming, what they do, and how, how people need to think about not just dropping it in an LLM in an enterprise setting, but thinking through the steps, how it might fail, and how should we protect against certain things, right? The design of it becomes more and more important down the line, for sure.
Yeah, I think you're right. From that perspective, it was a great idea. It was a great set of experiments to go show, here are things that we're going to have to think about to go to the next step. And right. I kind of feel like you and I are going to have to sit down and put our heads together for a little bit and go, okay, what did we learn with all those years of building those systems, both conventional and machine learning based? Say, okay, how would we really design this system? And maybe I've even got some old hardware around we can dig up. So we'll have to look at that.
Yeah.
Cool. As we go to the next thing we were talking about, it's kind of related to this, which is really, how do you structure and measure and evaluate these systems? There was a really interesting article from Datadog that you and I were reading, where they were talking about all the different ways to look at whether it's evaluate, is the model faithless, is it hallucinating, a whole bunch of different stuff that they had, and ways to go test. I thought it was a very actionable article too.
Yeah. So one of the things you might notice with LLMs, that benchmark numbers are flying everywhere, right? And often there's talk of, are we over optimizing LLMs to do really well on those benchmarks? It's kind of like, are we building an F1 or are we building a street legal car, right? They are completely two different things. F1 won't navigate on bumps or potholes, right? You will, they are not practical, right? So the article by Datadog was, I think, very timely, is that the benchmarks or the test or the framework selection has to be dependent on what that LLM or the AI system, or even a traditional AI model or machine learning model, is designed for, right? So if you don't have the right benchmarking parameters in there, it's going to test for, it's really, they will give you flying colors. So it's what they say, you have a really optimal answer for the wrong questions. So it may be solving wrong questions, but when you are trying to use the system for the real case, and in the benchmark you don't have any matrix to measure against those real use cases, then the benchmark in itself is not the right tool to measure, right? So
Well, and I think the other point too is it's not just what was the model or the tool designed for, but what is your business application? You've got to design something that matches works in both scenarios. To
Yeah.
just use an off-the-shelf benchmark,
Hmm.
you may find, yeah, it looks really shiny, but when I
Yeah.
actually go use it for my use case, maybe I do need that four-wheel drive truck because I got to drive up the side of a mountain, or maybe it won't fit in my parking garage because I didn't measure the garage, and now I can't fit my shiny new truck in it.
Yeah, yeah, that reminds me. I had in my previous neighborhood, somebody bought a Cybertruck and they did not measure the height, and it sits outside their garage every day. But anyway, besides the point, but it kind of highlights the even in benchmarking, people are talking about how logically it can solve problems and things like that, right? The RAG is the other one. How honestly it is able to stick to it. Is it right retrieval? Is it picking the right information from the RAG retrieval or not? Those all need to be part of the benchmark studies. And the way I see it, the benchmark, it's almost like test-driven. What we do in software stack, right? We don't have a standardized test kit. Maybe that's for security. You can run through some of these stuff, but when you are feature testing, it's very tuned to what problem each of the systems are solving, and those tests are written against that. So for business purposes, when we are benchmarking certain AI system, traditional ML or whatnot, the test needs to be designed around the key problem they are solving. Because that's very important, or else you would be measuring and giving it green light and it fails apart because we didn't test the edge cases, which need to be part of the test suite, right? There's a happy path, and then those are the edge cases where typically the machine learning models would fail, or even AI models would fail, right? They need to be part of the whole test suite.
Yeah, no, I think you're onto a super important point there. And then I think the other thing Datadog covered nicely is not only how do you build these tests. It was all aimed to use Datadog's tooling, but you can do a lot of that with other tools as well. But how do you measure all of that as you're going through? Because it's not just enough to build the evaluation. You need that data somewhere where you can make decisions based off of it.
Yeah, I think measurement is also very, very important, right? So in terms of accuracy of, say, a binary question or a multi-choice question, then the accuracy makes sense, right? But you need to be very careful. For example, you are predicting something which is 97% of the time yes, and then the 3% time no, and the model is always predicting yes, and you will see the number 97%. Oh, that's really an accurate model, but the 3% of the cases is not flipping over rightly, right? And maybe it's a fraud detection model. And if you're not catching those 3%, the model is useless, right? So a lot of those benchmarking and this test has to be got down to that level, right? What is it really testing? Because a lot of the truth can be hidden within the statistics, and a lot of things which look really good may not be really that good until you go down to that level and looking at the confusion matrix to figure out, is it really doing the numbers correctly, the precision recall, all of them are correct or not, right? So in terms of, again, if you're predicting literally like a RAG kind of a setup, right? Is it, because it would come back with a non-deterministic answer in terms of the language, but is the concept correct, what it retrieved, and did it answer truthfully, kind of a thing, right? Those designs has to be made with a lot of importance for it to work.
Well, and they had another interesting idea around that too, which is, and I think this would be pretty applicable to when you put a system in production, which is they were doing some sentiment analysis, if you noticed, of the user's responses or the user's questions.
Yes.
And I thought that was really, really interesting. I know you've done some work on just general internet sentiment analysis.
Yeah. So the sentiment analysis is very important when you have a chatbot like an interface, right? Yeah. How, it may be answering to the questions of the user in a way that the users are not finding it to be helpful. Even though for benchmark, those are the right answers, but it is answering in such a way that it's kind of making the person irritated, right? It's like, I just told you this, but why you're telling me about that? And they often, humans are not very expressive in terms of, I'm binary angry and I'm happy. They're in a gradient between 0 to 1, right? So it becomes important to have a sentiment analysis tagged on the answer they are providing. They could be passive aggressive. They could be sarcastic about it, right? Oh, that was really helpful, and that was in a sarcastic way, and the LLM is very happy because you got a positive response to it. So So it's very important for calibrating a lot of those models around being, giving a good customer experience. I think that's where a lot of these systems are designed for, right? So it's not there are machine learning models and AI models which talks to other decision engines and other steps in the business process. But when you're interpreting with a human and trying to be helpful, then you got to account in that additional dimension of how much how you really made that person happy or annoyed.
I'm chuckling because I'm thinking about if that tool I was showing you the other day that we'll do a demo of in the near future was actually paying attention, maybe it would have stopped having one of the models answer randomly in French and Spanish or whatever language it felt. It actually answered everything the same as the rest.
Yeah, I mean, for LLM, it's like, okay, it's answering in German. That was the right answer because the translated version, it conveyed the right information, but it missed that it's conversing in English rather than German, right? So, yeah, it has happened to me in the past when it would comment stuff in another language, and I have to ask it to steer back to the right language and stuff like that. So,
well, that was one of the problems I think we both had with the early Quen model, actually.
Yeah.
Was it would get confused and switch into Chinese or just gibberish.
Yes.
And so once you get to Quen 2 and Quen 3, it got actually really good. But Quen 1 was a little dicey on what response you were going to get.
Yeah. It's possible that their benchmarking test was in Chinese, right? So it got the high score by, going into that language, right? So, it's... I think the testing and model selection, this cannot be standardized in a lot of cases, right? The methodology can be standardized, but what actual questions and the matrix that we are looking at, that has to be very much business use case basis.
Yeah, I think, as a takeaway, they give the benchmarks give a great view of a model conceptually.
Yes.
But you've got to look at that model specifically for your use case and do some evaluation to see, okay, is it going to respond the way we need? Because all models, different models and different families of architecture will respond differently. So you've got to choose, it's like choosing the right tool, right? You can't do everything in Java. You can't do everything in TypeScript or in Go or in Python or in C++. You've got to choose the right tool optimized for both the business application and the total solution you're going to do. Otherwise, it's fun to have a hammer, but it can't fix everything.
True. Some things are very obvious but often overlooked, right? Benchmarking is one of those things, right? So unless you are really in the weeds and trying to really make a AI model out of lab into an enterprise setting, then these things become really, really super obvious. That where you need to have the alignment and guardrails and what is it really performing the way you want it to perform, right? So, and we even haven't talked about like questions which are out of sample, like completely out of a distribution. How does the model handle that? Because that's where it really, you take a model from a lab setup, a development setup, to an industrial grade model where it is trying to handle things which are never seen before, right? So, and that's when you know that you have actually captured the fundamental physics of that problem rather than just fitting on the data, right? So,
yeah. So kind of in that line of thought, there was that other article we were talking about LLM oracles.
Yes.
It's interesting, right? Because they were training one model to try and explain why another model was giving an answer.
Yeah. So that was an interesting paper, and I haven't thought of that approach before, which was they were trying to explain what the model is doing by looking at activations. So just to give you a quick recap of what activation is, neural network, they take in bunch of input, they do math and produce an output, and based on how, what the activation function is, whether it they're measuring that activation level. So in terms of the vague way of kind of connecting this to an brain mapping, right? When they would put sensors on your head and see which part of your brain is getting lit up based on if you're listening to a music, eating certain things, you're seeing some person. So that's how you map how the different parts of your brain do different things, right? So they took that concept and applied another large language model on the top, which takes those activation as an input and try to explain what the thinking process of an LLM, which is often opaque, right? So you ask it to do certain things, it's going through its own internal activation, certain parts is getting activated, certain is not. You're trying to figure out what it is really doing. So that was a very, very clever way of, looking into the black box. It's not really opening the black box and mapping everything, but kind of drawing inference on top of it.
And this is a super important problem to solve because we're all using these large language model tools. And I was talking about Nemotron 3, which is 30 billion parameters in a small size. But by the time you get to some of the more commercial models, those are probably closer to a billion or maybe more, a trillion or maybe more parameters. And at this point, there's no real tools that have been built that let you go through and like step through each neuron or each set of tokens to know why did it decide to choose that token or the next token. And that creates some challenges when you're trying to figure out why does it hallucinate, for example, or how did it give this specific answer?
Right. So hopefully tools, I think the experiment they did was really, really tiny models. And the reason is that you have to run the activation multiple times with, again, input. So it's kind of like scanning the brain, right? You're showing lots of images, lots of different things, and kind of collecting data. And we are good at learning and finding patterns in a lot less amount of data versus a LLM, which needs massive amount of data to find statistical patterns. And it's the problem with stats, right? It needs a lot of numbers to figure out patterns within it, and that's why it's very, very expensive that way. But as this more tool starts to get more traction, it may be possible to do it to what trillion parameter models down the line. So,
which I think will be really exciting as we all get some better visibility, particularly those of us who are working with the tools, to know why is it making those decisions. Because as we've talked about in other podcasts and other papers, it doesn't take a lot to drastically change the output. It can be spacing, it can be misspell a word the wrong way, and you'll get a drastically different output, or put different punctuation in than you started with. And that all makes them hard sometimes to use for certain kinds of applications because you can't guarantee your output in the right way.
Yeah, correct. So, again, it's probably not detailed out in the paper, but if you can isolate regions of the activations which are related to safety or alignment, and you see certain prompts going through without those parts getting activated, that it didn't go through the safety filters or alignment filters, right? Kind of goes back to hey, why did this happen? Let's go deep down because there's so many different use cases. Only certain will have issues. You can narrow it down and then kind of tweak it and figure out what's going on at that level. That helps the researchers quite a bit, right? So it's an interesting tool for sure, and I need to play with it at some point. But, yeah.
So we've covered a lot of cool stuff today. What closing thoughts do you have?
Well, the activation paper was really, really novel, but, and then the use case of the locker was the other one that kind of piqued those were the two interesting angles where you are throwing an LLM into a dynamic world where people are attacking it, not just, using social engineering, but you have objective functions in that particular problem was, hey, one is to answer the question that user is asking. The second objective function is to maximize your profit, right, and not go in red. So how does the system behave? And kind of without guardrails, it's failing. As you can see, right? It kind of tells a story that LLMs or AI systems are in its current form not designed to have multiple different objectives, right? It's often being helpful, and hallucination. All of those are kind of artifacts of trying to be helpful down the line, and they lose focus on the objective of maximizing the profit, which is kind of as a system prompt. It's not built in at a granular level to maximize the profit, right? So, so carefully thinking through application of AI system and traditional model for the business use case is very, very important in those cases, right? And then uncovering of the black box using activations and some other methods is getting also very, very important, because we would automate a lot of expensive decisions using AI down the line. It's now a matter of feeling safe and how do we ascertain safety, and how have you tested, so that the framework of testing becomes more important. So I see that these three things are interconnected in a very, very strange way, but all of them are needed for it to be an enterprise-grade solution.
I think you're right. And I think it also goes back to one of the papers we read a couple months ago about training LLMs to say no when they're uncertain.
Yes.
I think it's that combination of all the pieces that get to something where it's not just being a very friendly tool, but it's actually being a very effective tool. So I think we've got some design homework to do.
Yeah, I think designing, these cost function to be multi-objective is basically probably what it is, right? Boils down to, it's not always, am I predicting the right next token? You
Yeah.
cannot have that one objective function do multiple different things. We have to bring in the additional objective function as we are designing the cost function for some of this AI system would become more and more important. And how do you calibrate the weights even? Like, I'm going to give this being helpful 50% weight and also the business objective 50% additional weight. How do you calibrate that? Is it even possible to dynamically adjust those weight? I don't know, right? So those questions will be answered as we go into more and more adaptation of these systems.
I see a whiteboard in our future. I see a whiteboard in our future.
It's fun stuff, right? Thinking about how we think.
Yep. Well, I thank everyone for joining us. I hope everyone has a happy holiday. I think everyone should have a great one. We appreciate it. Please like, subscribe, drop some comments so we can see what people are thinking, what content you enjoy, what would you like to see more of. And we'll continue with a little bit of mad science, and you'll see us in the new year. So thanks all.
Thanks.